This is our photosensitive switch circuit diagram.
Using an LM74 op amp.
Each of the op amp pins are labeled to match the circuit diagram. This is a list of the resistors that were used in the diagram, and right there is the transistor. The op amp chip will change the output voltage to the transistor depending on what the input voltages are.
This is us constructing our circuit on a breadboard, which we'll be using for packaging as well.
This is being done in a library with no special tools. Obviously we have a problem with the circuit here.
We were testing our circuit with a 6 volt that we just used out of a calculator, which works just fine.
After a little bit of probing with the multimeter, we found out our resistance values were off. Had to go back through and change it, and the LED light is not part of packaging. It was for testing purposes only.
Our problem ended up being that the resistors going to the ground off the voltage divider from the photocell weren't large enough, causing not enough voltage to go through.
This is the working model using 6 volts out of a calculator. As you can see, when the sensor is put in the dark, the light turns on, switch turns on. When it's put in the light, the switch turns to closed.
Trimming the leads on the resistors for easier packaging.
Try to get it as flat to the breadboard as possible so that we don't knock anything off while packaging. Making sure not to trim them too short. Test fit them before you trim them.
There's the finished circuit on the breadboard with the power source leads on the left and the switched outputs to the light on the right.
We packaged it in an iPhone or Apple headphone box, and right there is the photocell, output leads, and input voltages. And that's the finished product.